I'm Ramon Jose. I'm a principal engineer here in Moshel. Well, one thing I find interesting working at a construction site, you tend to see different things going on all at the same time. You see tunneling going on, like seeing a tunnel boring machine. You could actually get into the tunnel and see how the tunnel boring machine works. One thing you have to avoid is making mistakes of, for example, setting out the piles on the wrong place. If they end up putting the piles on the wrong place from your setting out using your instruments, you may have to contact the consultant and check whether any solutions can be done. One thing you have to avoid is removing the pile, because the solution may be just put another pile in. And one of the problems that you have to avoid on site is, for example, you have put in reinforcement, cages of reinforcement for the base slab, for example. Before you pour the concrete in, you have to make sure the reinforcement are in the right place. They put in the right diameter, the spacing, etc. So if you made a mistake in checking and you managed to make a failure of spotting on the wrong place, it's too late once you pour the concrete in. So bear that in mind, is that once you pour the concrete in, that's it. Okay, one of the projects that you could be involved as a civil engineer is that you may be involved in inspecting existing bridges, different kinds of bridges, and when you're there, you may involve with measuring the size of the beams and finding out, annotating, sketching out the defects of the beams or the members, columns of the structure. When you finish the day's inspection, you may the next day you may go in the office and produce calculations and to work out the capacities for the bridge and check whether the bridge can still sustain the loads that's in. When a graduate comes in, the first thing I usually like to give a graduate is something which is interesting but still challenging to him. And the first task will be produce sort of sectional properties of a member, working out the inertia, centroid, and plug that into the computer, produce software analysis, computer analysis of a bridge, for example, or a building frame, a portal frame, for example, and then produce results from that, like bending moment diagrams, shear force diagrams, and I might ask him at the end to interpret the results. Will it make sense for that? Once he's got all the results, then I ask him to produce calculations, designs, size the members, what sort of steel reinforcement required for those sort of forces, to resist those sort of forces for the member. And once he's got all the designs, I might ask him to do a drawing for it, a sketch, so that we could put a sketch to pass on to the contractor to be built.